Hi, everybody. This time we're going to be calculating with density. We're going to be doing some mathematical problems with the equation for density. And sometimes we're going to be solving for density, sometimes mass, and sometimes volume. So a little review. This is our equation for density. Density is mass divided by volume. Density units will either be grams per cubic centimeter or grams per milliliter because a cubic centimeter is equal to 1 milliliter, and volume will be measured in either of those, and mass is going to be in grams. And we're going to do a collection of problems. Now, the way you set up a problem in science is like this. First thing we're going to do is write down what we know. We're going to read through the problem, take a moment, write down all the information we have with units. Units are very important in science. And we're going to put a question mark next to the thing we are solving for. That's very vital. We're going to write down the equation in its proper form. Then we are going to put numbers and units into that equation. Again, units, very vital in science. And the answer with correct units. So let's go through a few examples. First one. The fluid in a car battery has a volume of 125 milliliters and a mass of 155 grams. What is its density? So when you look at a problem like this, first thing you do is read through it once. Then the second time you go through it, pull out the important pieces of information. So this fluid has a volume of 125 milliliters. So I'm going to write that down. It has a mass of 155 grams. And if you have this on a piece of paper, notice I underlined that mass. You can underline that volume. Make sure you can pinpoint and visualize what the important pieces are. What is the density? So density is what I'm looking for. And I always like to put that down with a question mark. I know my goal. I will never get to my goal unless I identify what the goal is. Now my density equation, the basic equation, is density is mass divided by volume. The equation is solved for density. I'm looking for density, so I don't have to do any algebra. I don't have to look for a different form of this equation. The next thing I do is put these numbers plus units into the equation. So mass is 155 grams on top. Volume is 125 milliliters on the bottom. I pick up my calculator and it says when I do that, and I have these done ahead of time, that's going to be 1.24 grams per milliliter. Now, notice where the units come from. Grams are on top, milliliters are on the bottom, so my units pop right out of the calculation, grams on top of milliliters. Not too hard? Okay, let's do another one. Try this one, hit pause, try this one on your own, same format as the last one, and then we'll go through it together. All right, here goes. An ebony carving has a mass of 275 grams, a volume of 207 cubic centimeters. What is the density of the carving? So that's step one. Write down what you know, what you're looking for, plus question mark. Your equation is density is mass divided by volume. We're looking for density. The equation is solved for density, so life is good. Then I just put the numbers plus units into the equation. So 275 grams, volume 207 cubic centimeters. Do the division, and when I do that division, I ended up with 1.3285. Each one of these had 3 digits. I have to round this off to 3 digits. So 1.33, what units should go on it? Grams per cubic centimeter. In science, units are very vital, very important. A number without the proper units is useless. So you have to have proper units on numbers. This one's a little bit different because we're solving for something different. So let's look at it. A thermometer contains 8.3 grams of mercury has broken. What is the volume of mercury that has spilled? Now, first off, you should not be messing with mercury thermometers. They should be purged from your life and the universe because mercury is a hazardous chemical. But let's say one has snuck through, and this is our situation. 8.3 grams. That gram is a big hint. That is our mass. The mass is 8.30 grams. Let the units be big hints of what you're dealing with. What is the volume? Volume is what we're after. That's my question mark. That's what I want. I don't have enough information to do this, but yes, you do, because we can look up the density of mercury. The density of mercury. Now, this chart was in our course, and mercury has a density of 13.6 grams per milliliter. Where did I get those units? I got those from the top of the chart. What equation? Well, density is equal to mass divided by volume. And if we do some algebra, the volume, if I solve for volume, I'm going to multiply both sides by volume. And to get volume alone, divide both sides by density. So volume is going to be equal to mass divided by density. If you are not good at algebra, write this down. So you've got this equation in your pile of useful tools. I'm now going to put the numbers into the equation. 8.30 grams divided by 13.6 grams per milliliter. When I do that division, I ended up with 0.610. Now, what units should go on there? Well, it's a volume. So what unit is the volume unit here? It's milliliters. But where did that milliliters come from? Use your units as little helpers to make sure you're doing things correctly. I've got grams divided by grams per milliliter. And if you remember from fractions long ago and far away, you invert and multiply to divide by a fraction. Grams cancel grams, we end up with milliliters, and that's where that milliliters comes from. Alrighty, let's do another situation. Sometimes when we're dealing with odd-shaped objects, we need to find their volume by something which is called water displacement. If you've got an irregularly shaped object, it can be placed in a graduated cylinder. You notice the volume of the water before, you notice the volume of the water after, and you subtract to find the volume of the object. So let's say I've got a little plastic dinosaur. Before I put the plastic dinosaur into a graduated cylinder, the volume of water is, let's see, this is 4 milliliters, 4.2, 4.4, 4.6, 4.8. So this is 4.8 milliliters before the plastic dino goes in the graduated cylinder. After, it's 5.2, 5.4, 5.6 milliliters. So what is the volume of the plastic dinosaur? Well, it's going to be 0.8 milliliters. That is the volume of my plastic dinosaur found by water displacement. How much water was pushed out of the way by this irregular shape? It's commonly used technique when finding the volume of something odd-shaped. And that technique, and applied to density situations, was first determined by a fellow named Archimedes. Archimedes was a very famous Greek scientist, lived more than 2,000 years ago. And let me tell you a story. There was a story that an ancient Greek king had commissioned an artist to make him a gold crown. And he gave this artist a collection of gold metal. And the artist presented the king with this beautiful, beautiful crown. Well, people started whispering in the king's ears that this crown was not pure gold, that the artist had maybe cheated him. Well, if you're a good king, you do not like to be cheated. And so the king wanted to determine, was the crown pure gold, or had the artist cheated him? But it was a beautiful crown, and he did not want to destroy the crown in order to determine it. The question went out to the learned people of the region, and one scientist, Archimedes, was taking a bath one day. And as he lowered himself into the bathtub, he noticed that the water level rose. And by doing this, Archimedes came up with this concept of water displacement, and that you can use water displacement in order to find the volume of an irregularly shaped object. The story goes that Archimedes was so incredibly excited about this discovery that he went running through the streets of Athens shouting, "Eureka, Eureka, I have found it," naked, of course. And then eventually the test was applied to the crown. Now, what was the outcome? I've heard two outcomes to the story. One, that the crown was proven to be pure gold and that the artist was awarded. The other outcome was that the artist did cheat the king, and he was not rewarded and treated very badly. So how it ended, I'm not sure, but the story about Eureka and Archimedes in the water has gone down through history. Let's do one more of these problems, and here's what we've got. An oddly shaped copper object its volume is determined by dropping it into a very large graduated cylinder. The water level was originally 100 milliliters. After it was submerged, the water level rose to 215 milliliters. I want to know what is the mass of the object. Now, this is a couple-step problem. So the mass is what we're looking for. Okay? The volume can be found using water displacement. It rose to 215 milliliters. It was originally 100 milliliters, so the volume of the object is 115 milliliters. And we are told that this object is copper. If we look up the density of copper, copper has a density of 8.92 grams per milliliter. With this information and armed with our density equation, density is mass divided by volume, we can solve for mass. So let's take a moment, do a little tiny bit of algebra. We're going to solve for mass. To do that, we're going to multiply both sides by V. And what that's going to give us is mass is volume times density. Again, if algebra is not your superpower, write that down as a different algebraic rearrangement of the density equation and use that when you need it. Now we're going to put the numbers in here. Volume is 115 milliliters. Density is 8.92 grams per milliliter. The mass ends up being 1025.8 grams. We started with three digits, round that off. 1,030 grams is the mass. And that is the mass of our irregularly shaped object. And one last question. If you were asked to put that in kilograms? Can you do that? Absolutely, you can do that. That's not a big deal. Going from grams to kilograms, you move that decimal 3 places. 1.03 kilograms. All right, my friends, that will do. There's some homework problems like this, lots for you to practice. And of course, I've got some work out there on the online to help you. See you later. Bye-bye.